Hello guys, this is your next question of MCQ. Try to find the answer for this one. Okay, is there any error or something? This is very simple, I know. I'll count till 5, find the problem, or if there is no problem, tell me the answer. 1, 2, 3, 4, 5.
This video is sponsored by Dev C++, a fast, portable, simple and free C and C++ IDE and code editor for Windows. Dev C++ uses MingW GCC as its compiler, and it can also be used in combination with Cygwin or any other GCC based compiler. Dev C++ have low memory footprint because it is native Windows application and does not use Electron. And it is immensely popular due to its light footprint, yet giving you all the features you need, not to mention that it's free. So download the latest release for free by clicking the link in the description field.
Oh, it was very fast. So let's look at the answer. Yoo-hoo, the answer is this one, this one and this one, and so the answer would be A here. Oh my god, I again kept answer in A. No problem. This was very simple, I know. So let's look at the next question. That is not going to be simple. So this is your next question, and here if you notice, I'm assigning this one to some object here. Okay, so now if you don't want your destructor to be called at the same time, you have to create a permanent object. Okay, before you was just simply writing like this, okay, this one only, and here it was just this one. So you are not assigning the created memory to some real-time object so that its scope can be extended to this whole scope. Okay, you was not doing like that. I mean, if you want your base object not get destructed at the same time, you have to assign that memory to some object. Okay, now this object is having full scope of this one. Okay, now when the program control goes out of this boundary from this start to this end, when it will go out of here, these two will get destructed. So now we will just see that. I will try to compile this. This is 15, right? And run. See, base constructed, this one also constructed. Before, this destructor was coming in between these two here. Okay, you can see here. This is your previous program's output. Now what is happening? You are creating a base, you are assigning into B1. Now this B1 is holding that memory, and this B1 will not get destroyed until unless you go out of this scope. Okay, now it comes to the scope, or in order to explain you much better, your temporary objects are having scope of their line only. Okay, and these type of objects are having scope of where they were created, like from here to here. So this is the short answer for that. So I think I have explained it, and still if you have doubt, please ask me. I'll be very happy to explain in the comments. I don't have any problem in that. Hello friends, this is another MCQ question, and I'm not able to show you the full output here. I mean the full options. So I will just grab this one, try to paste it somewhere else. So this I have opened extra pan here for you. Here we can keep this. Okay, so let's look at the question now. Pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you would have come up with your answer now. So let's look at the answer for this. This is 26, right? 26, and there is no compiler, so at least compiler is not there. And there is this base child base destructor, base child base destructor. Okay, so I have chosen this question to demonstrate that what is the way of constructor calling. Okay, what is the sequence of constructor call here? So we'll see the first case here first. So in order to complete this one, your constructor should be called, and don't forget this is nothing but your temporary object calling here. Okay, that's why destructor is also called at the same time. So if you have attended my previous videos, you will understand that little better. Okay, now let's take the first case here. Your child is going to get created. This is default, so we will end up calling this one. And now first answer is, sorry, the first print is base. So when you call this one, it won't call itself first time. Okay, first it will go and call its base. Okay, this one. So this base will be called here. So this base is this one. That's why this base is coming here. We can see in the output. Okay, this base is coming first. After the base is created, child will create itself. It means after the construction of whole parent things, let's suppose there is another hierarchy, like this base is also inherited something from that. So in that situation, you should call that also, like here you can say some class or something like some class. In that, this some class will be called first. After that, you will come from there, and then only you will construct this base, and then you will come back here, then only you will go for child construction. So it works like that. If you have parent, you feed your parent first, okay, or you construct your parent first, then only you construct yourself, okay, because without parents you doesn't exist, right? So if you want to understand it like this, you can understand like without parent you don't exist. So first parents will get created, then only you will get created, okay. So that's why this base is getting created first, and after that you are coming here and you are creating yourself. And why this destructor is happening? Just because this is a temporary object. I didn't put this child destructor, I should have kept it. I just forgot that, so we can just keep it now. What should be the child? Okay, child destructor, and done. Let's recompile and check the output. See, this base is created. As I told, first base will get created, then child get created. But if you want to destruct this object, because this is temporary, so this is going to be get destructed in this line only. So when you are going to destruct it, first you will call your destructor, then only the base destructor will call. So in case of destruction, the order is reversed. Okay, you can see here. When you created child, you created base first, then you created yourself. But when you are going to destruct this child, you will call destructor of the child first, then only you will call the destructor of the base. Okay, so this is the way destructor get called in the inheritance hierarchy. Okay, so we are done here. If you have any doubt, please comment out. I'll see you in the next video. Hi, this is your next question. Try to understand this. I'll pause the video. I mean, you are supposed to pause the video. I'll count till 5. 1, 2, 3, 4, 5. And I think you have got your answer by now. So answer for this is, it is a compile time error. It is telling you that you are going to initialize this x, which is a constant here. Okay, you cannot do like this. You cannot initialize a constant inside your constructor like this. There is a way when you can initialize the constant in your constructor, but in order to see that, you have to watch my another video. Okay, so for this video, the answer is compile time error. You cannot initialize this 10 to this x, which is constant. Okay, so this is the answer. This is a compile time error. So let's look at the next video to see how you can initialize a constant from your constructor like this. Okay, so let's look at my next question. Hi, this is the next question, and this is the way you do that. Okay, the whole rest of the code is exactly same. I have just changed this one. Okay, so if you have watched my previous video, then only you will be able to link it. This is 29 video and you should watch 28 in order to get what is happening here and what I'm linking this to. Okay, or check out my whole playlist for whole bunch of videos like this. Okay, so we'll compile this and we'll see whether it is allowed or not. So this question is 29. Yeah, as you can see, it is totally allowed and the answer is 10. Okay, so for this, answer is 10 here, and this time the answer is B. Okay, so notice this. So there are few things. This initializer list is specially meant for that purpose, and this is one of the purpose. Okay, to initialize a constant variable of your class, you have to have one initializer list which is initializing that variable. Okay, so this is initializer list and we are initializing constant variable without any problem. Okay, so let's look at the next video now. Hi, this is another question, but looking exactly the same. I'll tell you where the difference is. Okay, this is how you are initializing and this is the reference of integer. Okay, this is reference variable and you're going to initialize that with 10 here. Okay, and this is the whole code, exactly looking like the same video you saw just before that. Okay, so try to think whether it is allowed or not. I'll count till 5, pause the video. 1 2 3 4 5. I think you would have got your answer by now. Let's look at the answer for this one. So this question is 30. There is an error, guys. It is telling uninitialized reference member integer reference. Okay, and you cannot initialize it like this. Okay, in order to initialize this, you need to initialize in some manner so that you can initialize it, and for that I think you should watch my next video. Okay, so for this video, this is an error. You cannot pass this 10 here, you receive it 10 here, and you are assigning that 10 to this x, which is of reference type. Okay, this is possible. For that you need to watch my next video. Okay, so I'll see you in the next video. Hi, this is the next video of the previous one, and this is the linked video. And if you notice, this is the initializer list, and yes, again it comes to the same thing. You have to use initializer list in order to initialize a reference variable. Okay, so I will just again simply compile this code and we can see it is working. Yeah, see, it is working. And if I will compile this, the answer is again 10 here. Okay, so for this question, answer is B. Okay, so there are lots of problem initializer list solve, and this is one of the problems. So before you saw that if it is constant, then also you have to use this initializer list in order to initialize a constant member of your class. Okay, and in case of reference member also you have to use initializer list. This is not going to work like previous one I showed you, right? This is not going to work if this initializer list is not there. Let's compile and check that. Yeah, see, the same error is coming. Okay, so let's look at the next video now. Please comment if you have any doubt. Hello friends, this is another question. Seems to be correct. Okay, so let's compile this code and check the output. Yeah, but before you think about it, I'm going to count till 5. Pause the video. 1 2 3 4 5. I think you would have come up with the answers by now, or maybe with the confusions. So let's look at the answer here. So this is 32. Compile. Oh my god, this is a compile time error. And someone really spotted it. Please comment. I want to see someone really got the answer correct here. Okay, so this x is private. This error is like you cannot initialize this x here because it is a private, and you have not done inheritance so that it is allowed. No, it is not allowed because you have used this base as a variable here, and if you want to use it like this, it means you are going to access some private variable outside your class. So that's why it is not allowed. Okay, it is like you are writing something like this, like base b and b dot x is equal to 10, which is not allowed. We all know that. Okay, so here also it is something like that only. Even if you are having this base b, it doesn't matter. Okay, so if you want to achieve the same thing, oh, I'm messing so much. Yeah, so if you want to achieve this one, you have to call some functions here like set value, and you have to pass this x there like this. Okay, this b will have one function, set value. It will take and initialize into x. Okay, you will pass this value here. Done. So after writing like this, we can just simply compile this and there is no error. Oh, there is some error, right? It is telling blah, blah, blah. Oh yes, we are creating base with default. Okay, you are not passing any value here, so this base will not be called. It is requiring a default base here. So in order to achieve that, we will give it like this. And now again compile. Yeah, this time it is compiling. And check out the output. Answer is 10. Okay, so I think we are done here. Let's look at the next question. Hello friends, this is another question. It might be looking like the previous one, but it is not. Okay, here is the difference, and let's understand this first. You just try to understand. I'll pause the video. I'll count till 5. Pause the video. 1 2 3 4 5. And I think you would have got your answer by now, or maybe you are in doubt. So let's check out the answer for this. This is G++33.cpp. Yeah. Look, there is no compile time error. We can run this. It is 10. So the answer is A here. And what is happening? I'll just try to explain what is happening here. Why it is allowed like this and why it was not allowed in the previous video. Okay, where we was doing something like this. B._x is equal to x here. Okay, the only thing is changed is this one. I have just kept this one here. Okay, and why it is working now? So this is our doubt. When it comes to initializer list, your initializer list can call the constructors here. Okay, so what it is doing, it is just simply calling the constructor on this B. Okay, so it is calling the default constructor, parameterized constructor of B1 and passing this value. Let's suppose there is this. Let's suppose there is another constructor, this one. Okay, and it is taking two values. Okay, just simply two values. So in order to call this constructor, you're just supposed to pass these two values inside this, and it will surely compile. We can simply check that. We'll compile this and we'll run this. It is giving you same output. That means it is running. So this time it is calling this constructor. We can check that. First, okay, here, second. Compile, check. Now it is calling the second one. Before it was calling first one. If you will not keep this one here and remove this one, now compile, check, it is calling the first one. Okay, it means the initializer list calls constructors on the objects. Okay, so that's it. If you have any doubt, please comment in the comment section. Let's look at the next video now. Hello Bangadoos. So this is your next question, and this is looking little easy question. So let's see whether you can give the correct output or not. So I'll count till 5, pause the video and try to understand. So I think you would have paused the video and got your answer, or maybe confused. Let's look at the answer now. We will compile this. What is this question? 34. 34, dude. What are you doing? Yeah. It compiled, that means there is no problem in this code, and now we will, oh my god, what is this? This is not there in the answer because I cannot put some garbage, because next time if I will run, I might get something else. That's why I didn't put it here. Okay, so let's try to understand what is happening here. You are assigning this B with 10, 10 is coming here. You are assigning X to X. What is this? X to X means what? Which X is this? Is this X or this X? That's why it is confusing. Okay, so we all know there is a way to handle this problem. Just change the name, right? This X1 and this like X1 and this also like X1. You are good to go, right? Compile, 10, no problem. Just change this variable, but there is a way to keep this as X only and initialize this X into this X, and that way I will show you in the next video. So if you want to see, go to the next video now. And if you have any comment for this video, please comment out. I'll see you in the next video. So this is the follow-up question of the previous one, and this is the way we do that. Okay, and yes, I know lots of people will be thinking, oh my god, it's again an initializer list only, yaar. But yes, it is initializer list, and I'm going to cover everything in so much detail so that you guys will crack almost all the interviews. Okay, so this is the way of doing this. Even if your variables are equal, you can assign this X into this X using initializer list, because the pattern is fixed here. The compiler knows very well that in left side this X will only come, okay, and in right side this X will come. Okay, so it's pretty much clear. And if you will go in this one, there is no fixed pattern, like this X could be this X or this X or vice versa. Okay, so there is no fixed pattern, but in this situation, this is totally fixed. You are assigning this one into this one, and initializer list work that way only, that in left side your data member will be there, and in right side your parameters will be there of your class, sorry, your constructors. Okay, so this is how it is done, and I can show you that it is working fine. So 35 and bingo and dingo, yeah, see 10. So I think we are clear here. Let's look at the next video. Yeah, so this is another question. Lots of weird things are happening here. I'm assigning something like this 10 here. There is no base parameterized constructor. Then how this will get assigned here, and this is assigned here. Oh, blah, lots of things are happening. Okay, so I'll just count till 5. You just think about it and come up with the answers. 1, 2, 3, 4, 5. I think you would have got your answer by now. Let's compile this. What is this? G++ 36. 36, you dumb. Oh my god, there is no compile error. How is it possible? I will run this. It will run. And the answer is 10 and 10. How come? How is it possible? You are not having initialized constructor. Parameterized constructor, but still it is assigned. 10 has gone to A, and then A has gone to B, and everything is working fine. It's because if you would have initialized your structure in C, if you are aware of C structures, this is C type value copying inside the structure variable. Okay, so if something like this is there, we can do like this also. There is no issue in this. Okay, I can show you that. We will compile this, we'll execute. 10 and 10 is only coming, but anyway, I'm not getting this Y, that's why it is like this. This time if I will return Y, it will return Y this time. See, 12 and 12. Okay, so this will go to X, this will go to Y. Okay, so this is perfectly valid code here, and this you can consider as a C style copy. Okay, we used to initialize data in C like this, and this is perfectly fine. But in C++, it is calling constructors, but still internally it's doing something, but still it is looking like C type member initialization, and it really works in C++ as well. Okay, so let's look at the next question, and please, if you have any comment, please ask. Hi fellas, this is again another MCQ question, but still looking exactly same as the previous one, right? But no, I will tell you, before I had kept this one into public section, now it is in private section. Okay, and now everything is same except this thing. Okay, public and private thing. So this is in private now. So what do you think? This time is it going to work? Think about it. Search in Google, do whatever you want. I'm going to call 5. I'm going to count 5. You pause the video. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think you would have got your answers. Let's look at the answer now. We will compile. What is this number? 37. 37. Oh my god, it is a compile time error. It is telling you could not convert this one from brace close initializer list to base. Okay, why? Because we have kept this one into private. Okay, so in order to achieve this initializer list thing, what I explained you in the previous video, you must have this as public. So if you will just take this one and paste it here, it will start working. Let's look at the code. See, it got compiled and we will run now. It is giving you the expected answer here. Okay, so this initializer list is only allowed to initialize data members if those data members are public. Okay, otherwise this initializer list will not work. So that's it. Let's look at the next question. Hello friends, in previous video we saw that we were initializing this with C style initialization. So this is nothing but the initializer list here. Okay, so it is calling the constructor and assigning the created object into this one. So that is fine. But what is this? If I will keep it like this, is it going to work? So the question is, if I will keep it like this, now I'm not keeping any initializer list here. Is it going to work? Think about it. I'm going to count till 5, pause the video. 1, 2, 3, 4, 5. I think you would have come up with the answer by now. So let's compile this. G++ 39. Answer is 10 and 10. That means there is no compilation error and everything is fine. And the result is as previous we was getting. Okay, and the result would be as it is. This one. So it is not like you don't need this initializer list. Okay, I already told you that initializer list is capable of creating objects with multiple values, like as we were doing in C. Like if it is 2 value, and let's suppose you are having two values here and this one integer y. In that case, I'm not initializing anything here. Why? Because just it's for the demo purpose only. So here this initializer list will happily call this base. Okay, we will compile this and check that. See, it compiled and it is giving you the output. That means it's okay. It is calling you, it is calling this base. Okay, so there is no error. But let's suppose you don't want this. So is it going to happen? No, this time it is error. Okay, compiling. So see, this time it is error. Okay, so we need initializer list for creating object with more than one elements. So if you have any doubt, please comment. I'll be very happy to explain that. So let's look at the next video now.
Hi friends, I'll count till 5. You just try to understand the question here. 1, 2, 3, 4, 5, 6, 7. Oh, yeah. So I think you would have got your answer by now. Let's compile the code. This one is 38. So this is 38. It compiled successfully. That means there was no error. Now compile. Constructor called. So answer is this one, B. Why only one time constructor called? If you are creating 2 pointers, then 2 time constructor should be called, right? You are creating this B right here. Then the number of time you want to create B, that many times this base should be called. But it is not calling that many times, just because malloc doesn't call your constructors. It's a raw memory creation. Like malloc will take size of base. What is this size? It is 1 maybe. Or for this I will just make it something like this. Okay, so this time it is 4. So 4 bytes will get allocated and it will get typecasted into the base pointer, and that memory is assigned to this one. Okay, there is no constructor call here, but here there is a constructor call. Here 2 things happen. One thing is like you will be getting memory from the heap or free store. Nowadays we call it free store in C++, which is different than the C heap. So that is not our concern. Our concern is this new will get memory from the OS. It will tell I want 4 bytes memory because this base size is 4, and on that memory this new will call constructor. Okay, that's why this constructor call is printing. So the difference is new calls the constructor, malloc doesn't call the constructor. That's why you are printing only one time this one. Okay, and in order to show you that because of this line only you are getting this output, I will just comment out this line and we can recompile it and we can be sure about that. Yeah, see, this constructor get called even if this line is not there. That means it is coming because of this line. So let's look at the next video. So friends, this is another question. It is totally different question than the previous questions what you have been watching since now. So just look at this question. Oh my god, the options are not available, right? Okay, I will just copy and something like this, and yeah, now this is your question and this is your options. So I'll count till 5, pause the video and try to understand what is happening. 1, 2, 3, 4, 5. So I think you would have got your answer by now, or maybe you're confused. So let's look at the solution here. This is 40. Yeah, there is no compilation error. We will run this and the answer is B1 called main and B2 called. So B1 called, main called, B2 called. So the B is the answer here. So why B is the answer? Actually, I did a trick. I created a global variable for this base 1. So global variables are always constructed before this main is being called. Okay, so whenever this print will come before this one base 1 is getting created and this B is getting created, actually this is a global variable, so it end up calling this default constructor here. That's why this B1 called is printing first, after that main called is printing, and after that B2 base 2 is
called. Okay, so this is pretty much simple here. So I think there is no doubt, I guess. So let's look at the next question now. Hello friends, welcome back. So in this explicit case, what will happen? Is it going to assign this 10 into this? I don't think so. Let's just compile this. So this one is 40. I'll just compile this one. And the error is this. You cannot assign 10 into this now, because this constructor is declared as explicit. If this explicit is not there, as the previous question was not having this explicit keyword, and now if I will compile this, it will compile, and if I will run this, it is going to give you the same output. But we are here to learn the use of explicit keyword here. Okay, so explicit means you are creating this constructor explicit, like you have to call this explicitly. You cannot just call implicitly. This kind of calling is implicit call. Compiler understand by itself that okay, I am assigning one parameter, okay, into base, and does base have one parameter constructor, and that parameter's type is integer? Yes, then I will just simply call that. Okay, but if you don't want that behavior, because that behavior is a misleading behavior, because sometimes what happens, you might create some function, like suppose you have created some function here, and here you want a base b. Okay, inside this function you might be doing something, but if you want to call this function, now you have two options. Either you will be calling with some object, or you will be calling with some number here. These two things are possible. Okay, and this is a misleading thing, whether you should be allowing this kind of things or not. Okay, so this is the reason actually we use explicit here. So I think I explained it. Let's look at the next video now. Hello friends, this is a revisit question. Okay, there is a guy whose name is Abhishek Yadav, I guess. He asked me this question, that he is confused whether we should include default constructor or not. I mean, in what scenarios we should go for default constructor, and in what scenarios you can rely on the compiler given default constructor. Okay, so this video is for that purpose only. So let's go ahead and compile this video. So as you can see, it is telling you that function base. This means this is a default constructor. It's missing because if you want to create this b1, this is a default call to the default constructor, whereas the default constructor is missing. Okay, but if just I will remove this copy constructor from here and we'll recompile this code, this code is going to compile, and if you will run this, it will run. So it means there is no error in this code now. So why removing one constructor worked fine? I mean, what was the requirement here? So the only requirement is, if you are giving constructor from your end, like any constructor, like parameterized constructor or copy constructor or whatever the constructor, in that situation you have to give default constructor. Okay, so that's the only rule. If you are giving any constructor, like this was a copy constructor here. Okay, so let's suppose you can just give simply a parameterized constructor like this one. Okay, so in that case also you need to have default constructor. Okay, let's suppose this is provided, and we'll just go ahead and compile this. This is not going to compile now. See, again the same kind of error. Oh, there is some another error here. This one, we'll clear this. See, it is telling this is missing. Okay, obviously, because we know the rule, if you are giving any constructor like parameterized constructor or copy constructor, in that situation you have to give default constructor if you are going to create a default object. There is no need of default constructor if you are not using that. Okay, so in that scenario I can just simply compile this. This is going to compile. Okay, there is no problem in this. See, this is compiling. So we are not using default now, so we don't need that. But if you are using that like this one, so this is the call to a default constructor. So in this situation it is error. Okay, so I think I'm done here. Let's look at the next video now. Hello guys, welcome to next video. Try to understand this. I'll count till 5, pause the video. 1, 2, 3, 4, 5. I think you will have come up with the answers by now. So let's go ahead and compile this. This is 43. 43. This code is compiling, so at least compile time error is not there. Now run this code. So the answer is base my function, base my function. So the answer is D here. Okay, why the answer is D? You are calling this my function with this new derived, and that pointer whatever you created is getting into this B. B is calling my function. So first time you are having derived pointer here, and derived also having this my function, but you are not calling this derived my function because we are not having any polymorphic behavior here. Okay, so in first case also you are calling this my function, and in second case also you are calling this my function, but in all the cases you are calling this my base function only. Why? Because your pointer is of base type here. Okay, so that's the reason behind you are calling this my function in both the cases. Okay, so I think we are done here. Let's look at the next video, and you will get the answer for this question in the next video. Okay, why it was working like this and what could be done to achieve different calls. Okay, so here is the runtime polymorphism. So we'll see that in the next video. So let's look at the next video now. So this is your next video, and this is a follow-up video. If you have not watched previous video, please go ahead and watch the previous video of this video, then you come to this video. You will be enjoying little more. Okay, so the only difference is I have written this virtual keyword here. Okay, so try to understand what is happening. I'll just count till 5. Pause the video. 1 2 3 4 5. I think you would have come up with the answers by now, so let's go ahead and compile this program now. This is 44, so 44, compile. I know compilation error is not there. Yeah, damn. Now this time we are getting this C as the answer what we expected in the previous video. Okay, but that time it was not coming. This time it is coming just because this virtual keyword is there. So what is happening here? My function is this function. Okay, this function you are calling, and you are passing this dynamically created object. One time it is derived, another time it is base. Okay, and you are getting into the base as pointer, and you are calling my function on the object. So this time, first time it is getting a derived object, that's why you are calling this derived my function. Second time it is calling base, so it is calling the base my function. Okay, so how this dynamic thing is achieved? It's just because of this virtual keyword here. Okay, there is something called virtual table and virtual pointer are being created here. Okay, so I know I have not explained virtual keyword much in my previous videos, and I am planning to create a series of videos which will explain this, how this whole virtual thing work. Okay, so for now you just keep in your mind that just because of this virtual keyword we are able to achieve this dynamic behavior. Okay, and to give you a slight idea how this virtual work, let's understand it this way. In previous video, this is the previous question here, virtual was not there, so just see this, only virtual is the new thing here. Okay, so virtual was not there in previous video, so in that situation it was calling, see I have the output of previous video, base my function and base my function. Why? Because the pointer type B is base type, so it will resolve at compile time. Okay, so the address of this my function will be return always this function. We all know all the functions are having their respective addresses. Okay, so this my function is having its own address in the memory, this my function is having its own address in the memory. Okay, so when this whole compiler is this program is getting compiled, compiler will check, okay, this is a base pointer, so let's copy this base my function here. Okay, so whenever you will call this b my function which is of base type, it will always end up calling this function only. Okay, it will never call this function because there is no dynamic behavior involved in this. You have not written the virtual keyword there, and in this video what I am currently explaining, virtual is there. In that situation it is not going to copy this my function address here. Okay, because now it knows that okay, this base is having polymorphic behavior, so in that situation it is going to resolve the address of my function, whether it is going to be this my function or this my function, at runtime, not at compile time. Okay, before it was working here at compile time, it was copying this my function's address and placing it here, and that was happening at compile time. That's why you end up calling my base function all the time. Okay, but here it is not happening at compile time, it is working as at runtime. Okay, and whenever you will call this, it will resolve, okay, what kind of object I am holding. Okay, this base pointer can hold base address as well as derived address. So that time it will check, okay, I'm holding the derived address, then I should call derived my function. Okay, and if I'm holding the base address, I mean the base type object, then I should call base my function. Okay, so this is the only thing you should be knowing, okay, for this video. Okay, so I think I made my point. Let's move to the next video. And yeah, please, if you have any doubt or you want to discuss something, please comment out. Hello friends, welcome to another video. I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5. So I think you have done your homework. Let's compile this. So this is 45. So 45. At least there is no compile time error. So answer. So the answer is 1020 1020. So let's look at this, why it is 1020 and 1020. And if you already got the answer, please move to the next video. So we'll see this base is getting this parameterized call. So in that situation, you are just calling this one and you are locally creating a base object. Yes, it is allowed. Okay, you can create a base local object inside the base class and you can do all this stuff, whatever is happening here. And yes, this is nothing but your this B. Okay, B is your this pointer and you are assigning this local B into this one, which is nothing but a copy. Okay, so your B is now pointing at 10 and 20. Before pointing that, you just printed that. That's because you got this 10 20 and 20 in first case, and after that you're printing it here, so it printed next time. Okay, so this whole thing is a valid code. There is no issue in this code. You might find issue in next video. Okay, so let's look at the next video now. Hello friends, welcome to next video. I know it is looking like the previous one, but there are some changes here. Okay, so just try to understand what is happening here. I'll count till 5, pause the video. 1 2 3 4 5. So let's go ahead and compile this. I think you would have got your answer, and I know lots of people will get shocked here. So, oh, what is this? Yeah, so at least compile time error is not there. Okay, now let's go ahead and run this code. Segmentation fault, code dump. Why? It's because this base B XY is creating problem for you guys. Okay, what is this? It's kind of recursion call. You know, you created this V1020, end up calling this base. Now again you are creating a base object which is calling the same function here again, and next time you will come here and again you will call here. Next time you will come call. So like this, it is a recursive call. That's why it is showing you a segmentation fault. Okay, I can directly show you that it's just because of this base BXY. Stay with me, I'll show you that. And this is 46 followed by 45.c. We'll compile this. We are going to run this and it is telling you the segmentation fault. I will check whether it is creating that core file or not. Maybe it didn't create it. It didn't create it. So maybe, okay, so this time it created. Actually, I paused the video and tried some options here. There is something called ulimit -c unlimited. You need to set this in order to get this core file. Okay, before, as you can see, there was no core file here. Okay, so now there is a core file. So now we can debug it. gdb e.out and our core file. See, it is telling you the problem is at 8th location. So the problem lies here. It means it is being called all the time. Okay, so the answer for this is runtime error. Okay, after a long time we are having this runtime error, right guys? So let's look at the next video now. Hello friends, this is another video. I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5. Oh, it was little fast. So I think you have your answer. So let's go ahead and compile this code. This is G++. Question number is 47. Compile. At least compilation error is not there. Now run this. Copy constructor and assignment operator. I think lots of people would have got your answers correctly. So the answer is C here. Okay. Why C? Because B1 is getting created, B2 is getting created. These two are getting created because of this default constructor. There is no printf here, so no problem at all. Now this base B3 is getting created and simultaneously it is being initialized also. Okay, so here comes the problem for lots of newcomers, that whether in this situation this operator is going to get called or this base constructor, I mean the copy constructor, is getting called. So always remember guys, whenever you are assigning to some object and that object is being created at the same time, okay, so this you can see this B3 is getting created at this particular line and you are assigning that, it means you are going to call the copy constructor here, okay, and copy constructors can be called like this as well. Okay, so now this is pretty clean that this time it is going to call this base one. Okay, so the parameter itself shows that, okay, B3 is an object which is of base type and it is passing B1, so this base and passing as base, so this is going to get called. Okay, so I can just show you that compiled and the same answer. Okay, so that assignment and this kind of calling is same here. Okay, but whenever you assign one object with another object and that object was created before, like this B2 was created here and you are assigning it here, so in that situation you will always call this operator function. Okay, you are not going to call this base, I mean the copy constructor, because that B2 was created not here, here. Okay, so this time you are not creating B2, you are just assigning it. Okay, B2 already have the memory for whatever you want to assign him. Okay, so that's it. This is the only confusion lots of people have. Okay, so I think I made my point here. Let's move to the next video. Hello friends, this is another video and this is not a revisit video. So pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you would have come up with the answer, so let's go ahead and compile this program. This is 48. At least no compilation error. If you run copy constructor is the answer for this. So there is this another way of calling your copy constructor. I explained this way in my previous video also. So this video will become like the exercise video for you. Okay, so I know lots of people would have given the correct answer, so let's move to the next video now. And yes, if you have any doubt or something, please comment out. If you want me to include some videos on some topics or something, please tell me that. Okay, I'll be very happy to get feedback from you guys. Okay, thanks for watching. Let's look at the next video now. Hello friends, this is another video. I'll count if I pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. So I think you have done your homework, so let's compile this. This is not just 19, it's 19.1. Oh my god. There is a compile error. Okay, so the answer is 1 here. Okay, both options are same, no problem. So why it is creating the problem? Because you have written this constant here. If you are writing constant, you have to initialize it. Okay, you might be getting some thing like that here. See, should be initialized. Okay, so this is not initialized, that's why you are getting error. Okay, so whenever you write constant member functions, constant member variables, you have to assign them. Okay, or I mean initialize them at the same time when you are constructing them. And there is another way of initializing these constant, and that is initializer list. Okay, so if you have watched my previous videos, you will get the idea what I'm talking about. So this is it. Let's move to the next video. Hello friends, this is your new video. Okay, so this time I have changed a very small place. This is static. Okay, I have kept static here. So if you know what is the behavior of static, in this case you will get the answer correct. Okay, so I'm going to count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. So I think you would have got your answer, so let's go ahead and compile this one now. This is 14.9. What is this? 2 here, right? So at least compile. Oh my god, what is this? Undefined reference to base y and x. Oh my god, this is a compilation error. Why compilation error? Look, the error itself is telling you the correct thing. Undefined reference to y. It means you are just declaring it. There is no definition for this x and y. Okay, whenever you write static data member inside class, you have to explicitly define it. If you are writing static in this class, you have not given the definition for this by writing something like this. You need to explicitly write something like this: integer base and then your variable name. Y is equal to, let's suppose, 10. Or if you don't want to initialize it here, no problem. You can just simply keep it as it is. Okay. And another is X. Now this time if you will compile it, it will successfully compile for you. See, I will clear this screen, enter. See, it got compiled. If you will run this, it will give you 0 and 0 because you didn't initialize it. If you would have initialized it with 10 and 20, it will give you 10 and 20 as output. I mean 20 and 10 because I'm just printing X and Y. Yeah. So I think you got the idea here, right? You cannot just simply write static integer X and Y, I mean the static data members, without giving the definition for them. And this is not the definition, this is just the declaration part of this X and Y. Okay, that's why you got that error before. Undefined reference to Y and undefined reference to X. Okay, so I think we're done here. Let's move to the next video. Hello friends, this is your new question. I'll count till 5, pause the video and try to understand what is happening. 1, 2, 3, 4, 5. So I think you got your answer. I know you got your answer. Maybe, yeah. Compilation error is not there now. Compile is what is this? 3, 2, 7, 5, 6. It means garbage. Okay, so the answer is C here. Oh my god, all the time answer is C. No, I should not keep it like this. Why it is like this? And yeah, it is a garbage value. Yes, it is not changing. I mean, I don't know. It's not changing. Yeah, you can see that it's not changing. But still, yeah, it is a garbage value. And why it's a garbage value? Because whenever you call a parameterized constructor and there is this initializer list kind of initialization here, then there is a pattern. First, this will get executed, then this will get executed. It is not like this one will get executed first and then it will execute. No, there is a order. Okay, so whenever you call some parameterized constructor or default constructor or any constructor which is using this initializer list, then the order is first come first, second comes second. Okay, so the first one is initializing with Y plus 1. So initially Y was nothing, so it was holding a garbage value. You incremented that garbage value by 1 and you just copied that into X. Okay, next time you are going and getting that value, whatever you passed, 5 plus 1, 6. 6 is getting into this Y and this whole thing is done. After that, you are just simply printing that. That's why Y is getting 6 because 5 plus 1 is 6 and this X was some garbage value. Okay, that's why you got this garbage and 6 as the answer. I think we are done here. Let's move to the next video now. Hello friends, this is your another video. Try to understand this. I'll count till 5, pause the video. 1, 2, 3, 4, 5. I think you will come up with the answers. So let's go ahead and compile this one. Oh, at least compilation error is not there. So, oh my god. The answer is D. Garbage, garbage. Oh, garbage, garbage. Oh, garbage. Oh, garbage. So, why garbage? You are having this X initializing with 10, but it is taking this X and this Y, not this X. Okay? So just don't get confused here. This whole variable access thing is depending on the scope it is used in. Okay, so this print is a function and it is going to use this underscore X and underscore Y, so it will look into its own scope. So its own scope is this one, starting curly braces and curly braces. You have not given any declaration and definition for this one, so it will go up in the hierarchy. Okay, so it works like that. So up in the hierarchy means it will look into this class first. So this class is having X and Y, so it will directly take from here. Okay, it will not take underscore X from here. Okay, let's suppose you was not having this one, you are just simply having this Y. Then what should be the answer for this? So the answer should be 10 and garbage. We can compile this and run this. See, 10 and this is garbage value. Okay, so as I told you, if it is not getting in this local scope, it will go up in the hierarchy and up in the hierarchy and up in the hierarchy until unless it reaches to the global one. Okay, so this is the global one. You cannot run from here to somewhere else because this is the end of this file. Okay, this compilation unit. And yes, it will look for the different compilation units as well. okay? Because you might be writing it like this: x turn integer x, and you are not giving the definition for this one, control x, and after this main itself you are giving this integer underscore x is equal to 30 here, okay? So in this case this x will become 30 now. Let's go ahead and compile this. See, 30, okay? If you are not writing this x turn here, there is a problem. Compiling, see, it is telling redefinition of this x, okay? So it means by writing this x turn here, you just declared it, and here you defined it. X turn means you are telling that I will be getting this underscore x from somewhere else, okay? And that somewhere else is this one or the different file, like this is 51.cpp. I could have included some another file while I'm compiling, and in that file this underscore x could be there in that file, and that has to be in global scope. It should not work in, I mean, it would not work in from some local scope. Got the answer now? Let's move to the next video. Hello guys, this is another video, and this is not exactly a follow-up video, but still there is some video like this before. If you are watching this whole video in the series, you will notice this, okay? So let's try to understand what is happening here. I'll count till 5, pause the video. 1, 2, 3, 4, 5, and then yes, this is the option always, okay? So I think you have come up with the answers by now. Let's check this out. Oh my god, segmentation fault. That means runtime error, okay? Second time we are getting the runtime error, and the same reason, okay? Before, if you remember, I was calling parameterized constructor. Inside that, again I was calling parameterized constructor. This time I am doing the same thing, but with the default constructor here, okay? So this whole thing will work like this. You will come into the main, you will try to create this B. This B will end up calling this default constructor. This default constructor is telling, I want to create another B. Okay, you want to create, no problem. You just go ahead and create that. It will call itself again, okay? It will come inside, and another time it will tell, I want to create another B. Okay, you create, it will go and come back. It will tell, I want to create another B. So like this keep on happening, okay? That's why it is a segmentation fault. If you want to see, I can just compile this whole thing with, what is this, 52, with this -G option. 52, where is that 52? Yeah, compiling and then running. It would have created a core dump file, then gdb your executable and the core, okay? Enter and the run. See, it is telling you the error is coming at this line because you are calling again and again and again, okay? So there is no error in this line actually. Actually there is no error at all. The error is lying in the logic here. You are calling yourself again and again. This GDB is still very smart. It is telling you where the error is coming, okay? Let's try to do something like create some variable, global variable. Integer glb is equal to, let's suppose 10, and you will keep on checking glb is greater than 0, sorry, less than 0, and I will do this. If it is yes, we'll return this. I don't know, we can write this return in this constructor, but still we can give it a try. Oh my god, not GLD, GLP. Oh my god. Compiling, it is compiling and it is running. Oh, wow. Enter. Run, it is giving you the output. Okay? Inferior, exit. I'll run this. Yeah. So the answer is, I mean, these many zeros. So now, at least this time, you didn't got this segmentation fault because you have the termination condition. So I proved my point that it was working recursive, okay? So when this GLB reached to the 0 and it got -1, in that case, it is false. Sorry, in that case, it is true and getting return here. And as it is a head recursion and you call yourself 10 times, that's why you are calling yourself 10 times with the printf also. That's why you are having this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my god, why 12? Oh yeah, we are calling it here also. Okay, so maybe it's 11 time here and 1 time here. Okay, so that's the reason. But yeah, I think I made my point here. Okay, no need to explain much. It is a recursion, guys. Okay, so let's move to the next video. I will just undo this whatever I did here. Hello guys, this is your another video. I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. So I think you know the answer now. Let's look at so let's compile the code. This is nothing but G++ 53. Compile successful, enter, run 10 and this one. So the answer is 10 and garbage. Okay. Oh my god, this time I didn't copy it here and here equal. I forgot that. No problem. So why it is 10 and garbage? Just because of this scope resolution operator, guys. If you are writing scope resolution operator at front of variable, it will get the global scope. This one. Okay. That's why it is taking this X from here, not from here. Okay. In previous, I don't know which video, but yeah, in previous video, I showed that if you are not writing this here, it will give you double garbage. See, double garbage. But because of this scope thing, you can directly get this X from here. Okay, so this is the way of accessing the global one. Let's move to the next video now. So this is a new video. I know if you know what is the scoping thing, you will definitely get this video. Okay, so let's look at the problem here. I'll count till 5, pause the video. 1, 2, 3, 4, 5. And I think you got the answer here. We will just simply compile this. Let's go and compile 54. Oh my god, compilation error? Why compilation error? You are using this scope resolution operator, which is telling you that I will be taking this X from the global scope, which is this global scope. Okay, this one, okay, but there is no underscore X here. That's why this error is coming, like underscore X has no been declared. Okay, so this namespace thing comes into this picture. Like if you are creating a namespace, you are putting this underscore X into this namespace, then it is not the global number. It is a global, but it comes under my space namespace. Okay, it is not a naked global variable. Okay, before it was a naked, like if you will write it something like this, then it is a global variable. It doesn't come under any namespace. Okay, so in order to access this, you can just simply write it like this. So just to show you that now it is going to work, we can just simply compile this one now. It is compiling and giving you 10 and 15. So for that matter, D should be the answer, but no, our answer is compilation error. So compilation error, this one. Okay, so there is another tricky question in next video. So let's move to the next video. Hey, look at this question. It is little bit different, I know. So I'll count till 5, pause the video and try to understand what is happening. 1, 2, 3, 4, 5. So I think you would have come up with the answers. So let's check out that. This is 55. Oh my god, compilation error. Why? Because, okay, we'll see this. Definition is not allowed here. I mean, this namespace is not allowed here. What do you mean by this? It means you cannot have namespace in local scope. Okay, inside the functions like main and any other function. Okay, it should be in global scope. So we can just simply copy this and paste it here, and I think it will work now. I'm sure, I don't think I know what it is. Okay, so it is 15 and 10. In that case, this 15 and 10 is the answer, but no, our answer is compile time error. Okay, so I think you understood what I'm telling. So let's move to the next video now. Hello Bangaroos, this is a different question than all the previous questions. So I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you got your answers. So let's go ahead and compile this one. 56. And yeah, it compiled. So compilation error is not there now. The answer is 21212. So 21212. D is the answer here. Congratulations if you got it. If you didn't, let's understand what is happening here. So the number 1 and 1 is calling this one. So, and this is calling number with two parameters. So the two parameters constructor is this one. So this integer a and integer b is being called. You are assigning that x with 0, y with 0, and you are calling this c out with 2 here. That's why that 2 was there in the first time. Okay, now this call is done. You are coming back, you are going inside your constructor and you are printing this 0 just because this 0 is there, that is the reason. Okay, second time you are calling this and2. For this you are calling this single parameterized constructor, and this single one is again calling this double one. So this double one is getting called first. You are assigning this a into x, the same thing, and you are printing this 2. That's the reason this 2 is there. After that you are going inside and you are printing 1. So what you conclude from this? The conclusion is, whenever you call your constructor and that constructor is calling some another constructor, whether it is a parent class constructor or it's your own constructor. So if it is your own constructor, it is called constructor delegation. Okay, or even if it is parent class, it is called constructor delegation. No, I don't know, I'm not sure. Okay, just leave it. So if you are calling some another constructor from your own constructor, whatever you call from the first place, in that case it will not go inside this constructor first. It will just call that constructor first, it will complete that constructor, it will come back, and then it will go inside this constructor. Okay, I mean the own constructor it was calling first. Okay, so I think you got the answer. Let's move to the next video. Hello friends, this is your new question, and I just didn't copy this one here to here. Let me do that. Yeah, so try to understand. I'll count till 5, pause the video. 1 2 3 4 5. Oh, it was very fast. 1 2 3 4 5. Okay, so let's go and compile this one first. Dun, dun, this is 47. Compiling. Oh my god, what is this? There is a compile time error here, dude. Why? Because the reason is x is private within this context. Yes, you cannot use x like this if it is declared private here. Okay, no man, it is not just because your underscore x is private here. The reason is you cannot have this x here because it is not declared or defined here. Okay, so if you want to see how to initialize this x which is coming from here to here from this base number, watch the next video. So let's look at the next video now. So this is your next video, and this is the way of doing that. You have to call the constructor of your parent class, which is base number for now. Okay, and if you want to initialize this x, you have to have a parameterized constructor which is being called from here, and you are initializing whatever the number you want to pass. That number will come here and everything will just work fine. So try to come up with the answer. I'll count till 5. 1 2 3 4 5. So let's go ahead and compile this one now. 58. It compiled, there is no error in this. We'll run this, and 2021 is the answer. So the C is the answer here. Okay, again C. Oh my god. So we'll try to understand what is happening here. Number n1 is getting called, n1 is calling this constructor, this is initializing y as 0, and then again calling your base number. Base number is coming here, base number is initializing underscore x with x, and after that it is printing 2 on the console. That's why this 2 is coming. It is coming back because this constructor is done. It will come back, then now it will go inside your number body, it will print 0. That's the reason this 0 is coming here in the second place, and it will come out. Okay, now this is turn, I mean the turn is for n2. n2 will end up calling this parameterized constructor. You are again calling this number a. That's why this 2 is getting printed here in the third place. After that you are coming and then printing this 1. So that's the reason behind this whole thing is. Okay, so this is the way it work. I wanted to show the flow, how this flow work. That's why I included this MCQ in this series. So I think we are done here. Let's move to the next video. So this is your next video. Try to think what is happening here. Okay, I'll give you a hint. This base is private base. Parameterized constructor is a private constructor here. Okay, so is this program going to compile, or what is the problem here? So I'll give you your time. I'll count till 5, pause the video. 1 2 3 4 5. I think you got your answers. So let's check this out. This is 59. Okay, at least compile time error is not there. We will run this one now. Answer, and the answer is 10. Yoo-hoo, 1 0. It is not 10 actually, it is 1 0. Okay, there is a difference in between 1 0 and 10, and that is the difference here. Okay, so what you concluded from this B is getting created, so this B will end up calling this base default constructor. This base default constructor is using the constructor delegation method and calling parameterized constructor with the default value, which is 0. And yes, this base is private here, still you can call from the public base. Yes, this is allowed. This is private to the base class. Okay, but you can always call private method from the public method. Okay, and this is one kind of method only. Okay, so if you want to see error, you can just simply do something like this, like b1, and try to initialize something which will end up calling your base here. So let's go ahead and compile. This time it will give you error. It is telling this is a private thing. Okay, you cannot call it from outside this class. So this is private to this class. You cannot call it from outside, as this one is from outside and it is working just because this is public. I mean, this base is public, so you are allowed to call this from public area. Okay, but this B1 is supposed to call this parameterized base, which is private, so you cannot call that. Okay, so that's why you are getting this error. Okay, read this out, it will tell you why it is happening. So let's move to the next video now. Hello friends, as I said, I'll be giving that answer in this video. So this is the way we do that. I'll count till 5, pause the video and try to understand whether it is going to compile perfectly or it is going to crash in runtime or something. Okay, so I'll count till 5, pause the video. 1 2 3 4 5. So I think you will have come up with the answers by now. So let's check out the answer for this. So this is G++ 62, and yeah, it compiled successfully. We'll run this and it is giving you the answer is private. So the answer is 1, I mean A here. Okay, so why this friend class derived is needed here? Why? Because you are keeping this as a private. So if I will comment out this one, then in that situation it won't compile. Let's go and check that. See, it is telling you that function is private within this context. So you cannot call this function, which is of base function, from your derived class because it is declared as private in that. If you will remove this private from here, if suppose you keep it public, then there is no problem. We'll check that. See, it compiled successfully, and if you will run this, the same answer. Okay, so here we learned two things. If it is private, you cannot access it from here. Okay, so in order to make that possible, you have to keep your class inside this class as friend. Okay, and we all know that the reason behind using friend keyword in classes, it tells that this derived is my friend and this derived is allowed to use my private member variables and private data members. Okay, so whatever private is there, I'm allowing to this friend, and this friend is derived, so that's why we are allowed to use this. Okay, so I'll make it in original form. So this was the original form, and yeah, it is compiling, it is running, and the answer is private. Yeah, so we're done here. I'll see you in the next video. Hello friends, welcome to another C++ MCQ question, and this question is not very hard. Okay, so I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5. I think you would have come up with the answers by now, so let's check out the answer now. So this is saying that it is having error at this line, like this base. So the error is this one. You cannot have something like this and then scope resolution operator. If you want to access base function which is exactly similar with the current function, you have to do something else, not this. Okay, and what? Let's check out the next video for that. I'll see you in the next video for this question. Okay, and the answer for this is compile time error. Okay, so A is the answer now. Let's check out the next video. Hello friends, this is another C++ MCQ question, and this MCQ question is going to clear your doubt. Actually, that is not a doubt. People doesn't ask those type of questions what I'm bringing here. Okay, people don't ask questions because they don't know what questions to ask. Okay, so see, as I'm keeping this friend class, my class here, and there is no my class. available here, and this base is telling that I want this my class to be my friend. Okay, and there is no my class existing here. So is it a problem or it is not a problem? Or I mean, what should be the answer for this MCQ question? So we'll try to see this here. Okay, I'll count till 5, pause the video and try to understand what is happening in here. So I think you would have come up with the answers by now. Now I'm going to tell you what was the main thing in this video. The main thing is this friend class, my class here. I am telling that I am the base class. I want my class as a friend. Okay, and in my whole program there is no my class. Okay, there are 2 highlights only. This is one highlight and this is one highlight. Okay, so there is only one my class keyword written here. It means this my class definition is not there. So how this whole program is going to behave? There's a reason I included this video in this. Okay, so we'll go ahead and compile this. Code 3. Yeah. Oh my god, there is no error. And if you run this, it will print I love C++. Okay, so we can conclude that if you are writing one class and you're telling that I want this class as my friend, even if this class doesn't exist, there is no problem at all. Okay, I can write any damn thing here and it is going to work. Okay, see, control save, I'll compile this, I'll run this, still it is working. Okay, but you cannot do this with any other thing, right? If you are telling that I will be using something, then you must have the definition for that, at least a declaration for that. But here we don't need anything like that. So we are done here. I'll see you in the next video. Hello friends, welcome to another C++ MCQ question, and this question is, I don't know what to tell. I'm going to count till 5, pause the video and try to understand what is the problem in this. Okay, 1, 2, 3, 4, 5. I think you would have come up with the answers. So let's go ahead and compile this code. So this is 64, right? We'll compile this and hold your heart, baby. Oh my god. There is this semicolon missing in here. Okay, if you will be giving this semicolon correctly, it will compile and it will give you the expected output as I love C++. So lots of people might have got this output and they might have thought that what is this MCQ? This is very silly MCQ. Why did I include this in my video? But let me tell you one thing, guys. People just don't see the concept, like how good you are in the concept. And they might be looking for the people like they are looking at the code. They know what is right and what is wrong. Okay, I have seen people like they will just scan the code and they are not supposed to run the code. They will just simply scan the code by their eyes and they will tell that this is the problem. And no matter how tough that line look like, they can directly tell you that okay, there is a problem. What generally people do, they will compile it. The compiler will tell you where is the problem. You will go and look into that. But generally in companies, if you are working on some big projects, sometimes it happens like you don't know where is the problem, because it is not compile time problem, it is runtime problem. And if it is runtime problem, and if it is not deterministic problem, so you have whole bunch of softwares, or I should say whole bunch of programs, you need to find the problem in that. Okay, so that time your keen eyes or your experience, I should say, will work. Okay, so this is not best suited example, like I just hide this semicolon. Maybe lots of people would have found it. If you found it, please comment out. I'll be very happy to see that. And even if you missed, you can comment I missed that, no problem. But this was not the silly question. Don't comment. Okay, so I'll see you in the next video. Bye bye.